I think you can start. So, warm welcome everyone. So today's session is about math behind ZK, which is zero knowledge, mostly about cryptography, maths. So today we have Oleksii, who is a blockchain developer, zero knowledge developer at Panther Protocol, and apart from that, is also a founder of Skill Crucial. He has around 16 years of experience in IT industry, especially in blockchain and web development. Yeah, happy to have you, Oleksii, and welcome.
Thank you. Thank you. Okay, as you know, I'm Oleksii. I responsible the Panther protocol for development of the wallet engine, and I perceive myself more like elliptic curve cryptographer rather than zk knowledge proof, because past like 3 or 4 years I was digging deep into math behind them, because it's not enough to know math behind the curves. It's needed to know how to develop secure solutions, ensure that there will not be any backdoors and mistakes to lose data, because one mistake can bring a lot force. Today lecture will be about math in generic, in cryptography, especially zero knowledge. It's very important to everyone to understand it. But initially it was supposed to be 2 lectures, but it will be 1 hour. That's why I added homework at the end. And everyone who wants to dig deep into zero knowledge, they're supposed to finish it. Because if you will not be able to do it, later it will be more harder and you will not understand the concepts. Start of the mainly we're going about topics to the elliptic curve cryptography, because if something will not be understandable in the start, by the end I think it might be more clear. So let's start. Integer and prime numbers. Everyone knows what is integers. It's numbers like which doesn't have any mantissa, which now doesn't have any not complete part. So it's 0, 1, 2, or it might be negative, -0, -2, etc. It's all set of the typical denoid. Prime numbers is positive integers greater than 1 and have exactly 2 cofactors. 1 and the number itself. So it might be 1, 2, 3, 5, 7, 11, 13, 17, 23, etc. Prime numbers are super important in the cryptography because it's guarantee security of the encryption, and the bigger prime numbers usually it's the more secure. There is by fundamental theorem of arithmetics, unique prime number factorization sounds like every number might be factorized from prime numbers. So for example, here you can see number 60. It consists of 2, 2, 3, and 5. They all prime numbers. So at the end, any number is a multiplication of the prime numbers, or set of prime numbers. This is very important. There are 2 areas in prime numbers in the math: testing of prime numbers and generation of prime numbers. There is testing is a process to test that number is really prime. So when you have like small numbers, like up to 32 bits, you can just try to divide it by all prime numbers and understand that prime or not. But if it's huge, like 100 bit, 200 bit, 500 bit, it's become it become very complicated to test that this number is really prime. So there is like some probabilistic test, Milli-Rabin test, which allows with probability guarantees that some number are prime or not prime with large number. And there is also deterministic test, but deterministic tests are usually used in the theoretical math because it has very high factors and very high time to test. Generation prime numbers is pretty straightforward, so it might be naive approach. So you generate like any odd number and try to test is it prime or not with verification. If not prime, increment by 2 and try again. This method is used in most cryptographic libraries. Also, there is a sieve methods. It's more efficient way to generate it, prime numbers. Usually, you will not be faced with generation problem, but it's nice to know about these methods and sometimes to understand how different libraries implement prime number generation, because depending on it, if it's predictable, it might be exposable to attacks or hacking. Relevance of the prime number. So security of the most crypto system relies on the integer factorization. Best known algorithm is generic number field sieve. Quantum computer could also factor number efficiently using Shor algorithm. It's used in zero knowledge as a prime number defined order of the group, allowed to create finite fields with specific properties, enable efficient arithmetic operation in these structures. I do understand that some of them don't know about field theory, some knows. Don't worry, you will know about it slightly later, literally in 10-20 minutes. So in zero knowledge, there is different application of the large prime number. So it's, for instance, secure groups. It's which can resist discrete logarithm attacks. Discrete logarithm attacks is trying to brute force the solution that key will correspond to specific signature, but as number is very big, if prime number is very big, it's very hard. But if it's might be factorized, it's easy to brute force. For example, there exists twist curve attack when attacker tries to make user to sign message with another curve, which can be factorized in small factors, and he can, with this signature, with some feasible time to get private key, for instance. So what we know from here also, prime numbers is used as snarks. It's to pair friendly elliptic curves, etc., etc. So for us, most important that prime numbers are required to define elliptic curve, because if elliptic curve will not be prime, it will be easy to hack. Modular arithmetic definition, basic operation. Modular arithmetic is a system of arithmetic integer where number up around upon reaching certain value. So easy called modulus. The easiest way to think about it is the clock. So in clock we have only hours, 12 hours. Oh, yeah, 12 hours, from 1 to 12. If clock tick goes behind the 12, it will be again 1. So think about it in that way. If I right now 6 p.m. and I add 7 hours to it, it will be 1 a.m. It will not be 13 a.m., etc. So this is modulus of the clock 12, number 12. Same works in backwards. So for instance, right now it's 2 p.m. I try to subtract 4 hours. It will be 10 a.m. It will not be -2. So -2 in the system is 10. This concept is very important to understand, because everything later will be set on the concept of the modulus. If someone don't understand this, please ask the question or raise a hand, because this is super important. If everyone understands, just put some reaction in the chat, etc., so we can continue. Because if you don't understand analogy with the clock, it will be super, super, super tricky. No questions, right? Okay.
Yeah, no.
Let's continue. So modular exponentiation. So, for instance, and same approach actually for modular addition. When you need to multiply in some modulus by some power. Naive approach, you can do just this operation like 2, 3, 5, 100 times, 10,000 times, 10,000 times, and every time do modular m. Or in case we speak as a cocklet, a modular, it will be mod 12. But this approach is super inefficient on the big numbers, because imagine if you want to power to like 100 bit, 200 bits numbers. So it may take, if you do it, it may take whole life to calculate it. So for this exists efficiency method, square and multiply algorithms. So when you square it, you can multiply by coefficients, and that way you reduce complexity from to logarithmic one. This is one key operation in many crypto protocols, including RSA. We in elliptic curves, we will be speaking about the scalar multiplication. It will be have same idea, but it will be not multiplication, it will be addition. I will explain it in details later. Multiplicative inverse of modular. So it's same as division in our real life, but in modular arithmetics, it's inverse. So it's inverse operation means we need to find, we have one number and we need to find another number that together, when they multiply by modular, they give number one. That's very important. Usually for this used extended Euclidean algorithm. So to find the greater common divisor and multiple steps, and then multiply together to find the greater common divisor. If we speak about clock, let's see, for the number 5, we need to think about that number from 1 to 10 for 12, which multiplication on which will give 1 in modulus. So it can be 2. If we go to 3, it will be 5 multiply 3, modulus will be 3. If we go to 5, 5 multiply 5 will be 25. Modulus 12 will be 1. This is like one of the examples. Not best one, but still. So you need always to have two numbers which multiplication by modulus give 1 in specific modular group. This is also very important to understand, because a lot of things in elliptic curves is based on this principle. Fermat-Leto theorem. Fermat. If P is a prime and A is not divisible by P, then I multiplication by P minus 1 will be equal to 1. This is theorem is very important because we will be calculating based on it lambda and beta of the elliptic curves, which allows to simplify calculations. Maybe it's not clear right now. Maybe it's a lot of words. I do recommend you to watch it again, this lecture, and especially watch the stages, because I really spent a lot of time preparing them. But when we go to the last part, everything all puzzles will come together, I promise. Let's go next. Discrete logarithm problem. It's the main problem of the hacking zero proof knowledge, or the hacking elliptic curve, hacking cryptocurrencies, Bitcoin, Ethereum, etc. It's called discrete logarithm problem. So you can know how to get from the number to the point on elliptic curve, but in order to get from the point to the number, it might take you can only brute force if there is no failed transaction, failed signatures, etc., which generated not in safe way. It's used, modulus used in the elliptic curves. It's used in short protocol, proof knowledge of x in the equation without revealing x. And today actually will be homework to do something with elliptic curves that prove that you know some knowledge. First one, it will be very simple, very generic, but if you do it, you will get a lot of understanding about it. And Fiat Shamir heuristic converts interactive zero proof to non-interactive one, relies on modular arithmetics, operations in finite field. Interactive zero proofs is a proof which need to interact with some site to get some additional knowledge about some additional variables. Non-interactive, mostly they used right now in blockchain. It's circuits which allows to prove something, someone knows something without interaction with third party. Modular groups also used in cyclic groups. So it means, what means cyclic groups? Again, let's go to the clock from 1 to 12. If you add, start from the 2 hours and add 2 hours, you will get cyclic group. 2 hours, 4 hours, 6 hours, 8 hours, 10 hours, 12 hours, 2 hours. It's never get to number 1, 3, or 5 because you add all the time number 2. And in this group, you will have like group 2, 4, etc. Or you can add 4 if you have smaller group. Cyclic groups is also very important because of the nature of the elliptic curves. They can implement twists, and twists allow us to have some cycles. We'll speak about existing twists on the Bitcoin, for instance, later. Group theory. Group is set of the items with a binary operation that satisfies 4 axioms. This is pretty straightforward axioms as a math. So, like if A, B in the groups and multiplication of the A, B also in the group, if we change sides, A multiplying on B or C same as A multiply B and C, etc. Identity elements, there exists an element in E such as A equal E and E equal A, and that all both equal E for all A in groups, etc. Inversive element for in group, for every element there exists at least one inversion element that equal some value. Usually it's 1, as we're speaking. Example of the group, it might be integers under addition, non-zero relations, rational numbers, or general linear group and for matrices over real numbers. So think about group maybe not as numbers, but some set of items which required, which follow some specific rules. Subgroup, cyclic group, I spoke already, so cyclic group, so gave example with clock. So if we add 2 to number 2, we will get cyclic group which will not intersect with other elements. Okay, group homomorphism and isomorphism. Homomorphism like special kind of function between two groups that respects and preserves the way the group works. A group is just a set of elements combined with an operation that follow specific rules. If you have two groups, let's call them G and H, and you have a function that takes something from group G and turns it into something in group H, this function is homomorphic if it doesn't mess with the graph structure. So if you combine two things in G and then apply F, it's the same as applying F to each thing first and then combining them in H. Isomorphism is like pairing. So for instance, so the two groups are the same in the way how they're structured, but they may look differently. So in zero knowledge, this term used to pair elliptic curve. So, for instance, when you have two different elliptic curves, but they have same amount of elements, but located in different ways. But using special function, you can pair a point from one elliptic curve to another elliptic point to on another elliptic curve, and this function will be isomorphic. Order of the group. The order of the group is just the total number of elements in the group. So, for instance, order as a group of clock we're speaking was 12 because there's only 12 elements. For instance, you can have group from 0 to 3. It will be also there's 4 elements. The order of any element in the group is the smallest positive number in such way that when you apply the group operation to that element and times, you get as an identity element. So it means that you need to do, for instance, 4 step. If you take 1, you need to do 4 steps with this element to come back again to this start. Let's go back again to our clock. If we start from 2 and we have element 2 with order of 6 group, so we need to add 2 6 times to get back to the same place where we started. This will be order of the element will be 2 of the group, and order of the group will be 6 because in this group which adds 2 always 6 elements. It can spill to the 7, etc. because we set up it that way. Use group theory used to short protocol subgroups. It's elliptic curve groups because it allows us to have to be very efficient in computation verification. Patterson commitments, but based on the difficulty of the discrete logarithm problem in certain groups. I think later in the course we will speak about Peterson commitments as well, not today on the lectures. Definition on a field and its property. Field usually has 2 operations, addition and multiplication. In a field, you can add, subtract, multiply, and divide, and everything still works neatly, but subtract is addition with negative sign, divide is multiplication by number inverted number. Field, the set of elements with additional forms and abelian group. Abelian group means that addition in commutative is commutative. So, and every element has an opposite, negative. So, in elliptic curve, we always have positive y coordinate of the point and negative. So there is always 2 elements. There's no way they have 1 element, at least in the classical math. The set of elements is coding 0 with multiplication forms and abelian group. This means that multiplication is also commutative. So multiplication in the group, on the clock, same 2, number 2 multiply 4 will be same as 4 multiply 2. And distributive for multiplication and addition work together in special way called distributive for. This means if you multiply a number by sum of 2 numbers, it is the same as multiplying every number and sum at the end. It's pretty straightforward algebra, maybe 5th class, but it's also very important that in the group theory, it's all follows the rules because field theory, because there might exist some fields that it's not following them. So examples of the fields, the rational numbers, the real numbers, the complex numbers, and finite fields. We are more focused on the finite fields. They have always a set of elements or notation on GF, especially if you will be doing some math research in Saga Math, it's notation GF. Saga Math is Sage Math, I think. It's a Python fork for complex mathematical calculations. I do recommend you to play around with it. So but after you do homework, not before. Notation, prime fields. Here is example of the, again, fields like 3 multiply or 3 plus 4. Let's look on the last two lines equals m. But if we have modulus 5, so it will be mod 5, it will be 2. Same as a power. No matter how many times or how big number will be the power, if it's modulus 5, it cannot be more than 5. What is used? What's some sort of things we use as field? First of all, it's field operation, field extension. So, for instance, when you have a smaller field, but for purposes of the mathematical task, you will extend field like it will be not 5 elements or not 7 elements, it will be like 21 elements. So you add extra elements with the same logic, with the same way how say calculated, but it will be bigger in order to do more complex things. And algebraic closure. I'm sorry for my accent. I not usually give so long lectures. So if you don't understand something, please ask. Algebraic closure of a field is even larger than fields that contain all the roots of polynomial from the original field. That means that any equation you can write using the original field can be solved in the new bigger field. So it means if all cases, all polynomials inside the smaller field, there, even if you extend the field, it will be applicable to the bigger field. But not opposite. So bigger field, if you find the way to decrease the field, but it doesn't mean that you will get all roots. Set of all polynomials with coefficient from the field. The set of polynomials with coefficient from a field means you're working with polynomials where the numbers coefficients that appear taken from a specific field. So if we have a field and we have a set of polynomials where coefficient come from f, the polynomial can have terms like x power 2x and constants, and the coefficients are elements of the fields. So whatever, like, I don't know, did you see film Hangover? What happened in the Las Vegas, stay Las Vegas, same as happens here. What happens inside the field, stay inside the fields and can't spill over this field because it's set up by the mathematical rules you set up or someone else set up. This is a short description of what it's about. Why important to construct larger fields? Because in larger fields we can find solution to the polynomials which we not able to find the way in the smaller fields. Solution of the polynomials equations means we can encrypt or we can create proofs more efficiently. Also, polynomials are used in error correcting codes to detect and fix errors in data transmission. So if data is corrupted, knowing the structure of the field polynomials, we can restore this data. For example, read Solomon codes. So they're used on evaluation for finite field. It's directly used in ZKP, including Stark. What is Solomon codes? It's imagine that you have a recipe book which for some reason you lost part of it. So you have space, floor, 100 grams, you don't know anything, what next, space, etc. So using Solomon codes, you can restore all data, what was missed, without issues. But this is the way how it should be encoded. So that's why it's important to know. Polynomials. Polynomials, the easiest way to think about it's like recipe. So when you cook something, you need 3 cups of this ingredient, 2 spoons of this that ingredient, and to take away like 5 grams at the end. This is the simplest way to think about polynomials. Polynomials might be long, polynomials might be have large powers. A lot of crypto attack based on polynomials. For instance, if signatures compromised and you can find relationship between signatures, independent one, not for generated, using polynomials, you can find secret key. So there is like 3 main operations: addition, multiplication, division. So addition polynomials, you mix 2 recipes together. Like, I don't know, you cook what you cook from the chicken for the biryani separately, biryani rice, and together mix. It's same idea. Multiplication, you like triple portion, fourth portions, etc. And division, you just try to split some meal to the small parts. I'm trying to speak in the way that everyone understands, so sorry if you came here to the very scientific talk, but the more people understand, the easier it will be to do homework. Evaluation, so polynomial evaluation, interpolation. So evaluation allows you to, you have a formula, and you plug just value, polynomial formula, just plug value and see what result it might be. So trying to get from the formula result. Interpolation is opposite. You have like if result, if x value 1, result should be 4, x value 2, result should be 7, and you know this data. By this data you can create formula which satisfy these rules. Using interpolation, polynomial interpolation used in many languages, not only for the Zero Knowledge. For instance, when I used to live in Singapore, there was guys who used polynomials to describe laws. So they made laws like how to say it? Sorry, I forgot the word. Government laws, etc. So if you go somewhere, you get fined, etc. They made it as a math formula, a polynomial formula, and I think it was corporate, not government, corporate. But corporate something very near the government, and they found that logical inconsistencies in the laws, and they allow to check that juridically in court using not only by prejudice but really by math formulas. So what's going on, etc. This is used polynomials. This is interpolation of the polynomials. So it's far away from what we're speaking right now. It's more complicated, but roots come here. So most of the processes in the real life you can describe as math formula, and you can describe as a complex polynomial formulas. Roots of polynomials and factorization. Roots, as if you see Kung Fu Panda, is a secret ingredient which makes the polynomial result equal to 0. So you have formula. If you put correct values, all formula should be 0. On this based many attacks on the crypto, especially elliptic curves. And factorization is splitting large formula, like with high power to the smaller one factors, because smaller factors is easier to solve rather than to solve very complicated many elements polynomial. Polynomials, commitments, and zero knowledge proof. This is polynomials also undermine the zero knowledge proof implementation. So you can, using polynomials, you can prove an elliptic curve mass, you can prove for someone that you are what you age without revealing any information about yourself, while using just mathematical formula and some constant numbers. Reed-Solomon codes we already was speaking about. So previously, if you lose some data, Reed-Solomon codes, if this data encoded properly with Reed-Solomon codes, it's allowed to restore this data. Very, very efficient, especially it's very used in zk snark. Now we're going to the most important part. So whatever was before, understand, not understand, I think it's like basic concept should be grasped. Now is the most important part of the whole lecture, because if you don't understand elliptic curves, later you cannot do anything, because this one try to focus, ask question, etc. Elliptic curve is a specific mathematical formula, a specific curve which are defined with this formula, where a, b is constant. For instance, for Bitcoin, a equals 0, b equals 7. So, and it's set of the points over the finite field size p. What means finite field? Because elliptic curve, you can understand, it's just curve, some mathematical figure on the paper, on the screen, etc. But when it's goes to finite field, it goes like we're speaking about clock. So, for instance, elliptic curve over finite field 7 cannot have coordinate 8. So if it's go to 8, it starts 0. It starts 1. If it go to 7, it's equal to go to 0. Same was as a clock, but right now we have 2 dimensions, x and y, and they're like cyclic. So if point go to another side or line go to another side, it continues from the opposite side, like some, I don't know, closed space. Here we can see example of elliptic curve over the finite field. On the left side picture, this is usually how it looks like, this formula looks like in the graphic. On the right side, what it looks like as elliptic curve on the over finite field. So you don't see any lines. But as you see, if lines cross the right end, it starts with the left. It cross right end, it starts with the end. So it's never ending. This means finite field. This is why it was important to understand modulus and what goes on with modulus or not. So far, so good. Is it clear why it starts from the left side? Please, if you have any questions, just feel free, I will be happy. But this part, these 2 pictures is very important to grasp what's going on with elliptic curve. There is 3 operations, that actually 2 operations on elliptic curve and 2 addition operations. First is point addition. Point addition is you have 2 points, you draw the line between 2 points, and line will continue till it interacts another third point which lies on this elliptic curve, which corresponds to this elliptic curve. Point doubling, same idea, but as you don't have any other point, you use tangent line to the current point and current curve angle. When you have tangent line, you imagine you draw it or you calculate it till it intersects another point which corresponds elliptic curve equation. Next thing is scalar multiplication. So usually you have basic point of the elliptic curve generator, named generator, and Scalar multiplication means to add this generator multiple times till you get the number you want to multiply. So, for instance, if you want to multiply by 100, you need 100 times add g. You need first make doubling to 2, and then 98 times to add point till you get point 100g. So it will be 100 scalar number multiplied on generator point g, and result will be point. Scalar division is same as scalar multiplication, but it's you need to multiply by an inversive number. So previously we were speaking about that modular inversion might be calculated by GCD, common divisor, GCD, greater common divisor algorithm. So for instance, if on elliptic curve you want to multiply any point by 2, you need to divide any point by 2, you need to multiply by inversion of 2. Inversion by 2 is this big number, as you see on the bottom. So it's not like trivial. If your multiplication by 2 is just one operation, point doubling, division by 2, it's almost 255 bits operation. 255 operations will be around. Let's speak about elliptic curve addition. What does it mean in geometrical terms? So we have point A and B. In the infinite field, of course, there is no lines. So these lines are drawn as illustration. Addition of these 2 points, sum of these 2 points, will be third point which satisfy curve equation, which intersects all 3, but it will be negated. So, for instance, if it's satisfies this point, satisfies this equation, we need to negate the point in order to get the addition point. That's the rule. For x, usually it will be always the same, but the question is y coordinate. Which is y coordinate? Doubling, as I say, we use tangent line. We don't have already point A. We take this point G. We draw tangent line which tangent to the current position of the curve. Find point C, and also negate against 0 axis. This is how it looks like. Why you need to know it? Because when you understand in your mind how it's geometrically works, it's easier to write the formulas of addition or subtraction or doubling. Elliptic curve discrete algorithm, it's most important part of the elliptic curve because you can easily do scalar multiplication generator by any point, but you cannot get, even though in generator and another point, you cannot get back scalar value without brute forcing. So there is no way to find back from the point on what number it was multiplied without like heavy computation, brute forcing, etc. That's why like cryptocurrency rise because of security of this approach. Let's watch parameters of the elliptic curve. First is order of the curve. So it means that max value of the coordinate x and y might be this value -1. So I'm speaking about Bitcoin curve because it's most well spread and easy to find information, easy to test, rather than to speak more specific to zero knowledge. Also, we have parameters in the formula A and B. So A was 0, B is 7, if you remember. Next thing is generator point. Generator point is constant. Everyone knows generator point because that's why everyone makes it the same calculations. and that's why we can just verify, for instance, signatures, etc., because all generator points in which equal 1 are constant. You can choose, you feel free to choose any other generator point if you want to do some custom solution or custom something. And this is order of the numbers. So this is max value you can represent inside elliptic Bitcoin elliptic curve, scalar value. So it means max value you can multiply is this value minus 1. But it will be also the same as minus g, because they are symmetrical. This is website I do recommend to visit, safe curves, where you can read all parameters of different curves which exist. Just before you go to the zero knowledge, etc. things, practical one, because you need to know what curves are existing, at least briefly, and what the parameters, what the consideration. This resource is very nice because it describes safety of the different curves. Symmetry. Elliptic curve are symmetric about x-axis. For every point of the curve, the point negative point is also on the curve. So this symmetry can be visually presented on Cartesian plate with any point mirrored across the x-axis. So it means that every point that on the top will be symmetrically flipped on the bottom. So, but this symmetry allows us some interesting thing. Let me just come back a little bit. As you see, point last number is odd. It means if we have symmetry, so one y coordinate will be always odd, and symmetric y coordinate will be always even. So because in sum they need to get these numbers. That brings us possibility to compress elliptic curve points. So, for instance, this schema used in Bitcoin, if prefix 04, there is no compression, there is like x and y. But if you see addresses, for instance, or public keys which starts from 02, it means that y coordinate is even. So you can easily calculate y coordinate if you know x coordinate, and opposite. But the problem of direct calculation y coordinate is to understand should it be which one of the two coordinates it should be, because for one x you can have two y coordinates. So for this reason we can encode or compress the key using 02 or 03 prefixes to know its order even. Twists. That's slightly beyond the scope, but it's really, I do think it's very fun to play with, especially when you know it. If curve has twists, it may have multiple cyclic groups, which means that for one y exists, for one y coordinate exists multiple x. For instance, everything that I'm speaking about Bitcoin curve because it's the most known and you can find a lot of information about it, but it's also applicable to any other curve. We have two different, for instance, we have P and N different. And the thing is, if we do -1, actually this type should be N -1. They both divisible by 6 without the rest. It means that every point has 5 more points, cyclic points. So we can calculate specific values like beta of P, lambda of P, beta of N, lambda of N. Means that if any number we can multiply by lambda of N or beta of N a couple times, we call back again to this number. It will be cyclic groups of 3 or 6, depending. And same of N. But most fun part, as both divisible, we can calculate the other coordinates like of this cyclic group without modular inversion, which modular inversion is very heavy operation to do. It requires multiple steps. What does it mean? It's called efficiently computable endomorphism, which allow to multiply any curve point by a specific value very quick by doing single mod p multiply. Means that I did that. So it means I can multiply beta of n on some scalar value, and I multiply lambda of p by of its coordinate to get the value corresponding new multiplication to the new coordinate. When you do homework task, you will understand this better, but it's really fun thing, and when you really understand it, you feel like you're a magician. You're just almost Harry Potter, but no one tries to kill you except this knowledge. Okay. How encryption of message works for the simplest way for elliptic curve. You find existent, you have a message set of bytes, for instance, 255 bytes of message. If SecP 256, you can encode only 256 bytes, 255 bytes. Bits, not bytes, sorry, bits. You try to, you imagine that this message is x coordinate of on the elliptic curve. You try to get y coordinate of it. If the y coordinate and x coordinates they lie down on the elliptic curve field, so they correspond to this elliptic curve calculations or elliptic curve formula, then you continue. But if it's not correspond, because it might happen, they might happen numbers or x coordinates that are not exist on the elliptic curve. It happens because of the difference between p and n. If you see p is more bigger numbers than n, so there is this amount p minus n amount of the points not exist on the elliptic curve, so it's possible. If it's x coordinate, you calculated y coordinate, and they are not point of the elliptic curve, you just add one number one to the x and try again. This number one you call padding. As many times you add one, it will be padding of your message. When you got the point which are valid for the elliptic curve, it will be your new generator. Then you multiply this generator by secret key, any secret key. Decoding words, and you will get a point which you can give to anyone. It will be encrypted your message. To decrypt it, you just give person the secret key, the point, and the padding. He is supposed to first get point, then divide or multiply inversion of the secret key, and remove padding. Then you will get your secret message. This is the most simplest approach how you can encrypt with elliptic curve. So in this scenario, your message point will be your generator because you start from it. No one knows it. Elliptic curve cryptography is more efficient. So if we go to our analogy, if RSA was writing secret message on billboard, then elliptic curve is like writing the same message on the postcard. Smaller, faster to write, and uses less memory and less operations. Elliptic curve is used in the zero knowledge. It's mainly zero knowledge based, like 90% of the elliptic curve cryptography plus polynomials. With it, you can prove that you know certain information without revealing the actual information. It allows you to create efficient proof ranges. And I'm trying to be very fast. I'm sorry if it's not everything understandable, but if you want to go deeper and if you want to go to the zero knowledge, you need to do homework. There's no other way. You if you never was familiar with elliptic curves, you will not get further without some practice. Let me explain. This screen, you can just view, find the video, or you can screenshot. All the tasks will require around, if you newbie, it will might require like 2-3 days to complete. If you understand coding and understand like elliptic curve, you may finish like in a couple hours. First one, you need to code GCG algorithm for modular inversion and get all cofactors of all numbers, which cofactor k and cofactor equal 1. Take primes 11, 13, 23. So what you have group of 11, you have group of 13 with modular 13, and you have group 23. And you need to get to write GCD algorithm for modular inversion and to go all numbers from 1 to 10, from 1 to 12, and from 1 to 22 with modulars, and find cofactors to them. It will allow you to understand better the concept. Next thing, code verification of elliptic curve. So you need to write a function which accepts x, y, and p. And you need to return true false if this coordinate located inside elliptic curve or not located inside elliptic curve. Use secp 256k1 Bitcoin curve because it has tons of material and all these things are done a million times, and you can easily find how it can be done. Next thing, code point addition, code doubling. And you shouldn't use any math libraries. You should do it by yourself. You should, because you need to do point addition, you need to do point doubling, except big numbers, big ins. For practice purposes, I recommend to use Python because it has big ins out of the box, and you can do it like in 10 lines of code each function. When you write it, you will understand how doubling and addition works better, and you will think back about these geometrical examples. Next task, to make scalar multiplication G multiplied by K. So you take generator, point from the Bitcoin and write the code which multiply by any number. Like function should accept key and return point, and you need to check that it works correctly. Code division of point by some number. So it's same as multiplication, but it's inversion value. So this is like together task 4 and 1. So you already have coded inversion algorithm, you have coded already multiplication, you just need to plug it together. Code retrieving y coordinate by x and x coordinate by y. So when you know one coordinate, you need to be able to retrieve at least one corresponding to this coordinate. But you need to also to verify it, every coordinate or this point. At this point, write down on the elliptic curve, because sometimes you can generate some values, but they will not be on the elliptic curve, and this will not be your fault, but it's nature of the elliptic curve. Next to task, encryption description using elliptic curve algorithm I described just a couple minutes ago. Code function which retrieves all x coordinate for single scalar value key. This is related endomorphism. So the trick here not to use modular inversion. So you have point, you have a scalar value, and you need to return all values, all possible points, like 5 more points and 5 more scalar values without using modular inversion. This will really give you deep understanding of how elliptic curve works. Code function compression, elliptic curve. So for instance, as I said, this y value might be even or odd, and you need to compress in the single line of x with prefix, and maybe decompression. And the last one, I especially didn't speak anything about signature in the Bitcoin, but if you do all these tasks and you read details of the Bitcoin signature, how they sign the messages, you will easily implement signing by yourself. Like it will take for you like 5 lines of code using like previous one, and verification signature. This will be first zero knowledge proof idea that you know the private key without really revealing private key, but revealing some additional value R and S. I do recommend to do it on Python because Python has lots of mathematical abilities like powers and big numbers, and you don't need to think about how to do some conversion like in JavaScript, but you can do this task in any possible language, even JavaScript. And actually, I was doing a lot of JavaScript, but I do recommend for scientific purposes, for exploration purposes, just use Python. That's it from my side. Thank you for attending the lecture. I hope it was helpful, insightful, and you was like familiar. I'm on Discord. You can add me. You can ask any questions, and I help you just to understand better elliptic curve for cryptography and ideas. But really listen to me and pay attention to it, because if right now you cannot do it and you don't understand it and you don't have will to get into it, later it will be super hard to understand what's going on, because all zero knowledge is based on the elliptic curve. If you cannot grasp it, it will be hard. But if you understand it, it will be the way more easy, very, very easy. Thank you for your time. And if you have any questions, just ask me.
Thank you so much, Oleksii. And I think we can wait for a minute. If there are any questions, please drop in your chat box. And Oleksii, can you also share us the homework related details? What programming language that they need to
I said I do recommend to do it in the Python. So native Python without any libraries is enough to implement all these things and tests.
Okay. Okay.
But if someone feel hard know other languages like Rust, C++, C#, or whatever, JavaScript, and they feel challenged with understanding Python, they can do it in other language. But this homework is really important, because if it's not done, it will be very hard, very tough to go further.
Right, got it. I think we don't have any questions for today's session, and I think we'll be sharing all the homework related details with you over email and in Discord. Thank you so much, Oleksii. It was a great session, and thanks everyone for joining it.